they're telling us the graphs of r equals 3 and r equals 3 minus 2 sine theta are shown, and they're asking us to find the area of this shaded region. You definitely have to have a firm picture of how these graphs are created. So if you're not sure, put them on your graphing calculator, and you'll find that r equals 3 is this semicircle, and it would start over here and trace up this way. And then r equals 3 minus 2 sine theta is the other graph. It would start here and trace like this. And then, of course, we want to find this region. And there's two things you want to keep in mind. The first is that the formula for a polar function's area is 1/2 of the integral for some specific angles of the function squared d theta. And the second thing is understanding how this area will be swept out by the function. It's the idea that we have a theta value and that theta is going to increase counterclockwise. So we're going to get images kind of like this. And I always picture maybe like a windshield wiper where it's like the windshield wiper is like hinged here, or maybe like a radar thing. But the point is it's sweeping out like this. And if we look at the function r, we can see that for this first half, this part that I'm going to color in blue right now, that's all going to be defined by this function. And then this second part, which is a quarter circle really, is defined by this part. So the only thing really to figure out for sure that could be confusing sometimes is what these angles are. For the blue portion, the angle definitely starts at theta equal to 0. So I'm going to do 1/2 the integral from 0 to, we'll figure this out in a second, but this is going to cover the blue part even though I'm writing it in green. That's awkward. We will change this to blue. And to find this upper limit of integration, you might have a strong sense that that upper limit like takes over at pi over 2, and if you trust that instinct, you're in good hands. That's the correct thing to think. But if you're ever in a situation where you can't quite tell where one graph takes over and the other one does not, you basically just want to figure out where this graph and this graph intersect. So if you had to, you could always set these functions equal to each other and solve them. So that would give us that 3 equals 3 minus 2 sine 2 theta, and if you were to solve this equation through, you'd find that theta equals pi over 2 is the place where these graphs intersect, which means it's where this other graph picks up. So this is the calculation I would use to find the blue area. And then for the green part, you can, if you want to, recognize that it's a quarter of a circle whose radius is going to be 3. So you could totally do 1/2 of pi times radius squared. Or if you wanted to make it look more calculus-y, you could do 1/2 the integral from starting at pi over 2 and then working your way towards pi of that function 3 squared d theta. Either one of these calculations would work. Then you just pop that in your calculator and see what it tells you, and you should get something like this as your answer. And if you have any problems putting that in your calculator, please let me know so we can figure this out and be awesome at it. Thanks.